Welcome everybody to the first meeting of Biddle Bootcamp. Thank you all for your interest, and I'm sure you all got started on a page like this. Maybe you heard about Biddle Bootcamp on Twitter or somewhere else. I didn't advertise it much, so I was surprised how many people responded. And so yeah, you all signed up, and if you go and look down at the curriculum, the first week we were going to go over the basics, and so that's what we're going to do today in the first lesson. Over this week, we're going to try to build about a 1,000-line implementation of Bitcoin, a mini implementation, inspired by this little project, TinyChain. Now, TinyChain, as you'll see here, and you can click on that link to get over here, it's pretty great. It's just one file, and you know, the real Bitcoin has many more files than this. Basically, any coin of any cryptocurrency of any complexity is much more complicated than this. So this really helps to understand kind of how Bitcoin works. But the problem is it's still pretty complicated. There's a lot going on. It's still 1,000 lines, and even if you understand how it works, it's not always clear why it works that way, right? Like you know, why are there fees? You know, like why do you have UTXO? Why do you have, you know, a blockchain at all? You know, why do you have blocks? Why do you have? Why are transactions organized the way they are with this list of inputs and outputs? You know, there's all these strange decisions that the Bitcoin designers made, and I propose that we understand these by kind of step by step building up an implementation of Bitcoin. And so we're not going to start with this TinyChain. This is hopefully what we're going to get to by the end of the week. And so I'm going to switch over here to the little presentation. And so yeah, here we have, this is kind of my proposal. Digital cash play in 7 acts. So what we're going to try to do is we're going to try to build kind of 7 versions of digital cash, pretending that we don't know what Bitcoin is, kind of. You know, we obviously know what it is, and that's where we're going. But we're going to start out with something so stupid and so basic, with so many problems, that I mean, I intend it as kind of a joke. Like, no one should use this first coin ever, and it's just a terrible idea. But with every succession, you know, we're going to remove some features that are problematic. So, for example, in this first coin, we use PNG images of actual pen and paper signatures as our signing scheme, right? On the internet, that's a terrible idea. A much better way of doing it is digital signatures. And ECDSA is the digital signature algorithm that Bitcoin uses. So you'll see in this first step, that's what we do. We take the dumbest part of this first coin and replace it. And with every successive step, and with some of these you might be able to guess what the step is if you know a little bit about Bitcoin, we'll add some features and maybe like 100 lines of code, and then hopefully by the end we have something like a 500 to 1,000 line program that has all the main features of Bitcoin. It has peer-to-peer networking, it has a blockchain, it has transaction inputs and outputs, it has proof of work mining, it has difficulty adjustment and a logarithmically decaying supply schedule, and an absolute supply cap. All these features that Bitcoin has, we're gonna implement them by this last step, but we're not gonna implement them all at once. We're gonna do them one by one, so we know why we're doing it. Okay, so the first step, PNGCoin. Like I said, PNGCoin is a terrible idea. It's like the dumbest coin I could think of. And why did we make the dumbest coin I could think of? Because then we can see all the problems it has, and we'll solve them one by one. And then we'll get a little bit better understanding why Satoshi made the decisions that Satoshi made. So, what is PNGCoin? Let's just assume it's issued by the government. What is a coin? Every coin is just a list of .png files, photographs, of physical signatures transferring the coin ownership from one person to another. So like, I'll give you some examples in the next slide. And so this means the coin is like a bearer instrument, right? If you can have this, this list of photographs, you can just kind of compress them into a single file, and you could email that money around. You add a new photograph. If the list the last item in the list of photographs is somebody else giving ownership of the coin to you, then you could add one more photograph at the end, giving ownership, kind of signing over ownership to someone else, and then you just email them the whole thing, and they can kind of look photo by photo and see that, hey, it started with the government, and then it was transferred validly every time, and now I own it. So it's kind of like this chain of ownership, and so like I said, full of holes, terrible idea. So how does it work? Well, this is where PNG coins come from. They come from our good friend Donald Trump. He issues them via executive order. He says, I issue 10 PNG coins to Alice, right? And then he signs it with his signature. Looks like he does that with a paintbrush or something. But he'll send over the PNG coins to, let's say, Alice, and now when Alice gets the file with this picture, she has a PNG coin, and if she wants to send it to Bob, what does she do? She writes a little thing out, on pen and paper. I, Alice, transfer 10 PNG coins to Bob, signed Alice. And this is Alice's signature, and people know Alice's signature, and if Bob gets this list of photos, he can look. Okay, it was issued by the government. Okay, it was transferred to me by Alice. Now this sounds stupid, but this is not that different from how certificates of kind of representing gold ownership used to work at old school banks. It's not that much different how checks work. You have to sign a check with your signature, and then the person who receives it can actually transfer it to someone else. They can, on the back of the check, they can sign, hey, I sign this over to someone else, and now that money is owned by someone else. This is actually not that much different than the financial system. Parts of the financial system worked 50 years ago. And, it also has some fraud resistance, right? You can look step by step, right? Pretend this second picture on the right here was replaced by this picture. If it said, I, Alice, transfer 10 PNG coins to Bob, signed Bob, this is obviously not a valid transfer, right? The signature should say Alice. If it was going to be it should be Alice's signature, right? And so, yeah, this is kindergarten level digital cash, but we have to start somewhere. And I plead with you, please take this project seriously, because in order to understand all the problems Bitcoin solves, I think this project is useful for showing all the problems that digital money can have, and so you'll appreciate all of the solutions Bitcoin presents by understanding how terrible PNG coin is. Okay, so here's some problems, right? Easily counterfeit, right? If we go to this website, you can, you can create some yourself. I issue 10 PNG coins to Justin Moon. Right? On the internet, I can counterfeit these. It's terrible. It's terrible. So easily, I think I forgot to type something there. This would mean easily forge. I think it was easily forge transfers, right? If Bob knew, if we go back, if Bob knew what Alice's signature looked like, he could just put it right here, and especially because it's digital, it's much easier to forge a photo of a signature than a real pen and paper signature. Because people may know that Alice only uses a certain type of pen, right? Which is a lot easier to detect physically. And so yeah, it's easily counterfeit. It's easily you can easily forge transfers. It's easily double spent, right? Alice could go here and she could go do this, transfer to Bob, and she could also transfer to George and Amy. She could transfer to 3 people at the same time, collect product from them or whatever is on the other end of the transaction, and now she just tripled her wealth, right? Because she was able to turn 10 coins into 30 coins worth of product. So it has horrific privacy and fungibility. Every single coin has the complete history of everyone who's ever owned it. So you could imagine a situation if Alice is a drug dealer, Bob might not accept this because he might think that someday our buddy Trump over here would, get real angry and take these coins out of circulation, just say they don't count anymore. And so that's a big risk, terrible privacy and fungibility. Fungibility means like, every coin is the same, right? Like one coin is not different from the other. And that's not the case with us, because you can see the entire history of who owned it, right? And you can kind of guess what they spent it for, probably, if you can infer that Bob sells snowmobiles, you can bet that Alice bought a snowmobile or something. Who knows? Terrible divisibility. You can only transfer all 10 at a time, and the government only issues 10 at a time. So if you want to buy something for 5 units, you're kind of screwed. You got to buy 2 of them. And lastly, it's very easily censorable, because it's issued by a central authority. And at any given time, the authority could say, "Hey, remember these I issued to Alice? Those don't count anymore. Those are bad coins. Those are bad now." And so you're really in the hands of the central authority. And there are probably some more issues, but really a lot of problems here. Like this is terrible money. Shouldn't use it. And let's implement it, right? Let's go. We're going to be good coders. We're going to actually implement this money. And so to do that, let's go to this repository. That's my username, SuperQuest Digital Cash. The link will be in the comments of the video. And what we're going to do is we're going to scroll down to the README, and we're just going to run through these steps. So open a terminal window, and first you want to check if you have Git installed. So all you got to do is type Git. If you get some output like this, that means you do have it installed. If you don't get this kind of output, that means you need to install it. You can click this link, I think, and find out how to install it. Next step, you need a GitHub account. And so I have one already. If you don't have one, click here and create one. I guess strictly speaking, you don't need it for this tutorial, but I think it's going to help if everyone has GitHub accounts, just so we can kind of collaborate and I can, see what you guys are working on a little bit easier. GitHub's a good way to share your code. And so last step is check that you got Python 3. And so what you're going to want to do is type Python 3 here, and this will just enter the REPL, the interactive command line thing for Python. And so you want to check that this number is above 3.6. If it starts with a 2, that's not good. And if it's 3.5, 3.4, those are all bad. You want either 3.6 point something or 3.7 point something. And you can hit Control D or exit. You could also go like this to exit and hit enter, and that'll get you out of that REPL. And once you have all, if you didn't have that installed, if nothing, if you had the bad version or nothing came up when you type Python 3, then you're going to want to follow this link over here to install Python 3. And so so lastly, we want to clone this project. This is a Git repository, so it's just like kind of like a folder of code for those of you who aren't familiar with Git. And I'm going to copy this and paste. Like in general, you don't want to copy and paste stuff on the internet. I mean, I think on GitHub it's pretty safe because I don't think there are ways to embed malicious things into Markdown in GitHub. But, I wrote this so I know that it's not a problem. But, if you're security paranoid, type this out word for word. And paranoia is good. So the first thing it does, it clones a repo in using Git. Then it changes directories into that repo. And by the way, these are all Unix or Linux, Mac instructions. If you have Windows, you're going to have to figure out what the analogous commands are. I mean, they'll be basically the same, but like the slashes will go the other way, stuff like that. And so we change directories into the folder. We create a Python 3 virtual environment. We activate the Python 3 virtual environment. If you don't know what that means, Google it. Then we install the requirements. This is just the requirements.txt file. Here it is. We can open it. It's just got a bunch of Python packages in it. Mostly they're related to the Jupyter. This is like the coding environment we're going to be using. There's Jupyter. Here's the cryptography library we're going to be using later. And Pillow, this is what we're going to be using for our PNGCoin. This is a library to manipulate images in Python. So those are the 3 main ones. The rest of them are like requirements. There's dependencies of those things, and then lastly we're going to run Jupyter Notebook. And so here we are. We've done everything. You can kind of usually you can see you're in a virtual environment because it'll highlight here on the left side of your command prompt. And so type out Jupyter Notebook and hit enter, and it'll say, okay, copy and paste this into your browser. So as you can see, there's a little server running for me on port 8889. Actually, I think I also have one running on, I'm running two of them by accident right now. Yours will probably say 8888. And it just says a little token just to make sure that, it's not getting, that you're actually trying to access this. So it's like an authentication mechanism. And so if you just open up a terminal window, enter that in, you'll see this beautiful little UI. This is called Jupyter Notebook. These are, this is kind of like a really nice way to interact with Python code, especially if you build it up like piece by piece like we'll be doing. And so you can ignore ECDSA coin for now. That's what we're going to do second. Right now we're doing PNGCoin. So PNGCoin.ipynb is like the finished thing. And I would encourage you not to look at that right now. Go to this PNGCoin workbook.ipynb. And so we'll open that. And so this is just like kind of the kind of prompts for what we're going to be doing here. And the way this class is going to work is I'm going to just kind of like live code this. And I want you to follow along and actually type it out with me. I don't want you to sit there and watch, because then you won't understand what's going on. You won't remember it, and it's a waste of your time and everyone's time if you're going to just watch. Please type the code in, and then you'll really, and then if you have a question, pause the video and play around with the code a little bit. That's the best way to learn. Okay, so just to give you an idea, just like a little overview, we're going to learn to open images in Python. We're going to learn to ask a user, and this is a cool thing about, so this is like a Python cell, right? So you can actually run Python code there. This is a markdown cell. It has markdown, so it's like a way to kind of make notes to yourself in it. And so that's what we're doing here. So we're going to learn to open images. We're going to learn to kind of ask a user to verify images, right? Like, so if you're looking at this, we'll be able to kind of loop through each one of these and say, hey, is this a valid from the government? Is this a valid transfer from Alice to Bob? And so we're going to create like a Python class that represents the coin. We're going to write a code to do what I just said, to kind of loop through all the signatures, the signature photos, and verify that the coin has a valid transfer history and that you can like be sure it has some monetary value. And then we're going to learn to serialize coins. That means basically put them into a binary format we can just like send over the internet or store on a hard drive or something. And then we're going to learn how to read that serialized format back into our Python program. And so the idea is here, we'd have this code, we'd be able to, if someone sends it to us, we could make another photo at the end of the list, serialize it, write it to disk, and then, send an email with that coin in it to whoever we're paying. And so it actually is digital money. Like, this is money you could email. It's just a little file, and that's it. And so yeah, let's get started. Let's kind of jump in, write some code. So the first thing we're going to do is we want to say from PIL. PIL is Python imaging library. That's what we downloaded. It's also called Pillow. It's downloaded from the requirements.txt. So they have this image class, right? And so with image, you can say img equals image.open. So you can open up an image and then show it. So I'm gonna send this out to kind of Never Neverland, so we don't have to see that anymore. Because the server just runs, we don't have to. That the window was the Jupyter Notebook server, so we can just let that hum along in the background. So let's import image, this image class. Let's open an image, alice.png. That's a file that you can see here. It's in our current directory. And let's show it. And so if we enter this, look at this. There's my trusty commander-in-chief, that son of a bitch. Okay, so so there's image.show. And so that's great. So we'll be able to, this is what we'll use to loop through the coin and kind of verify its transfer history. And so that's it for this one. Now we know how to open an image in Python and display it to the user. So the next thing we want to do is we want to say, like, given a image, like let's say we have this image here, right? We want to be able to ask the user, like ourselves, we want our program to be able to ask ourselves, like, hey, is this we want the program to show us the image and take input from us, like, hey, is this a good image? And then our program will do that for every image in the history of the coin, and we'll be able to see, like, okay, the image is good or not, or the coin is good or not, right? So this we're writing like a convenience script to help us validate whether coins are good or not. And in that sense, our PNGCoin's a little similar to Bitcoin, right? Like the onus is on the user to figure out if the coin's valid or not, right? Like in Bitcoin, you have to figure out what version of consensus you want to follow, and whether you want to accept 0 confirmation transactions or whether you want 6 confirmations. The onus is on the user, and that's kind of similar here in our god awful PNG coin, right? So what we really want is something like this. So we want to be able to take a file name and basically do the same thing we did here. Open it, show it, and then say, ask the user, hey, is this valid? And so let's say we have a function validate, right? And all validate does is it will take input from the user. It'll say, like, hey, I just showed you a picture. Does that picture make sense, right? Because our PNG coin isn't automated at all, because, like, we could do OCR or something and scan these, but this is like a stupid project. We don't want to get so complicated. So let's write this validate function. And all this does is, like, validates one transfer. It'll just, one image, it'll ask the user whether it's good or not. So in Python, this is how you ask for user input. And, once we don't, if you don't know what I'm doing here, it'll make sense once we run the code. So let's say, hey, hey user, is this a valid? How do you spell that? Is this a valid signature? And let's tell the user, like, hey, use Y or N. Those are the things our program will only accept those as input, right? And so then we'll say, okay, if user dot lower, let's just make it lowercase in case somebody puts an uppercase Y or an uppercase N. And then we'll just print it's valid. Else if user input dot lower, and I have a typo up here. So if you get the letter Y, let's say it's good. If you get the letter N, print it's not valid. That makes sense. So we're just asking the user to use their human judgment to see whether the coin is good or not, right? Whether Donald Trump's pretty face is there, whether he signed it with a signature. You don't want Alice's signature there. These are all really stupid. It's stupid what we're doing, but we're kind of walking through. We're trying to figure out from first principles how you'd go about seeing if some kind of transmitted value is good or not, right? And otherwise, let's say, hey, let's do it all over again, right? Like if they put the letter Z, we want the code to just run again. So this is actually kind of a recursive function. It'll just call itself, right? If they didn't if they didn't give us one of our accepted answers, we'll just run it again. It will just say, hey, is this a valid signature? And we'll just do that until it terminates by receiving a Y or an N. And so, yeah, let's execute those, and you can hit the A button to make A or B to make a new cell. And let's you can do display and verify, and as you see, this Jupyter Notebook has good completion. It actually was able to. It's able to. You see that? it's able to complete file names too. It's pretty nifty. And so if I don't have any typos or mistakes, which I'm sure I do, this code will work. So okay, let's get rid of that. So and let's run it again. Okay. So when I ran it again, it popped up that same image, right? But you see over here, there's a little user input field, right? And so it's asking us this question: is this a valid signature? And that's what this input does, right? It just gives the user a chance to to enter some input. And so I'm going to say, yeah, that is a valid signature, right? It is our treasurer, the person who sends out coins. It is his signature. And, you know, it's a valid number of coins, I guess. Who knows? It looks good, so I'm going to say yes. And then it prints it's valid, right? And this is kind of the first step towards writing a program that can validate these coins. And so, so next, let's actually write a Python class to start to... You know, we've talked about what this coin will look like kind of at a high level, but let's actually write a Python class that that implements this. So class Python def init. So init is dunder meaning double underscore, underscores on the left and right side. This is how you this is the code that runs when you create a new instance of an object in Python, or an instance of a class in Python. And so the first argument is self, and that's basically the it's like a raw object that's empty, nothing object. And this code will just take that and modify it however we like. And so, excuse me, sorry, I've got a cough. So the code we want to run here is we want to pass in transfers, and basically the entire history of these kind of photographs representing transfers of ownership. And then we'll say self.transfers. So we're just going to stick that on the class, and that's our coin. That's all it does. Is it's just a list of transfers. Remember, remember I said over here it's just a list of these. Here's the first one. Here's the second one. Easy peasy. And so that's our coin. And now we want to actually be able to create a coin and do things with it, basically to validate the coin. So here's how it will work. You'll say coin equals PNGCoin, and then you'll just take a list of you'll input a list of a list of these transfers, which will all be these pill.image, these image classes, instances of that class. And so that's what we'll do. So first, as our first image, it'll be image.open of Alice, the one, you know, this one we saw over here, which I'll close now. And we called that alice.png. We should maybe call that like Alice fresh or new coins or something. And the second one is image dot, or sorry, we want Alice to Bob.png. And so if we look over here, this is just, it's this one, you know, where Alice sends the coins to Bob and it's valid. And so that's the name of that file on our hard drive here, or in our directory. And so, so if you run that code, sorry, missing an S. If you run that code, now we can, you know, just play around with it. Coin. Yeah, so you can see the list of transfers, and you have images. And, you know, just to convince you that this Alice to Bob is actually the one, so I'm going to take the second in the list and say show. There you go. It's what we thought it was. You know, Alice sending our stupid coins to Bob. And so the next step we want to do is to be able to actually, you know, to take one of these coins. Well, actually, here, let's just before we do that, I'm going to make a bad coin here. And so we have one more file. we have this. I'll give you a little demo here. So we have this Alice to Bob forgery.png. I thought we did. It's called forged. And so here it is. This is the one we kind of joked about. I, Alice, transfer PNG coins to Bob. Signed, Bob. No, that should be, it's the wrong signature. We need Alice's signature, right? And this kind of, I mean, this kind of song and dance. It seems so stupid now, but this is what you do in Bitcoin. It's like you have to check the signatures every time. So much of Bitcoin programming is like some of the stuff we're going to do. It's like, you know, did the signature match? That's the key thing. And so we'll close that. And so what we're going to do is we're going to write some code that can validate. You know, it'll return true for this one because the second signature was actually good. And we'll return false for this one because, you know, the user inspecting the second signature here would say, no, that's bad. And so let's do that. So we can delete these. And so, yeah, let's just see. We had a validate. So what we're going to want to do is we're going to want to let's just copy this validate code. Okay, and make a couple extra lines here. And what we're going to want to do is we're going to want to say like for, and we're going to take a coin here as input. So now we're actually taking a coin as input, an instance of this PNG coin. And we're going to say for transfer in coin.transfers, transfer and transfers, let's show it, right? Let's show it to the user, and then let's ask the user, hey, is this valid? And you know, we're iterating from left to right, from the low indices to high indices. And so the first one will always be the ones that should be coming from the government, right? So if these were forged, hopefully the user would be able to spot that. And then so here, we want to get user input. So let's do that. So show it, and then we'll ask them, hey, is this signature valid? And then once we get the user input, let's just say like is valid equals. So this user input is just a string. It's just whatever the hell the user decided to give us. And we already have code here that can handle that. And and the thing is that we want, the reason why we're going to break this into two functions. And the reason is because if you remember this, if we went up here, we had this was a recursive function, right? If it didn't give us what we wanted, it would call itself. And we want to do that again. But we don't want to be able to, we don't want to, you know, if we don't get what we want for one given transfer, we don't want to run the whole thing with a for loop and do that whole song and dance. So we're just going to break this this logic we had. We're just going to break out this logic we had earlier into a handle user input function. You can paste that in there, and all it says is like, hey, did they say yes? If it did, and here let's no longer print. Let's return true, and if they said no, return false. And if not, let's call it again. You know, do the recursive thing. And so for each loop where we're going through these transfers, let's say, hey, if not valid, and that's our function. So how it works is it just loops through every transfer and basically asks the user, hey, does this look good? You know, starting from the first one, which should always be from the government. And then if the user says no, it stops. It says, hey, sorry, invalid coin. If the user says yes, it just keeps going. Does it over and over again until it runs out of transfers. And if it gets to the end of the transfers and the user hasn't rejected anything yet, then the program will say, hey, it's good. You have now checked everything, and it's good. So let's try this. So let's make sure we ran both of these. I don't know why that disappeared. So So we're all set up here, and now let's do validate. Let's validate the good coin first. And so it'll say, hey, is this signature valid? I say it is. You know, it looks like it was issued from someone in authority. I'm going to give it a, well, let's just say, let's give it a D. Uh-oh. Okay, good. We tested our code. I forgot to pass in, yeah, so this is a little bug here. So we're going to want, every time, before we do the recursion, we're going to want to get input again, right? And so, so yeah, we could probably, later I can see ways to refactor this, but I won't slow everything down. So let's try this all over again. And I'm just going to give it a D, right? I just gave it not an N or a Y. And so you can see how it'll ask me again, right? So our code's working. It checks to see whether it's, you know, whether we're interacting. And I'm going to say an N this time, and just see what happens. Oops. Okay, try that again. Give it an N. One more time. Sorry, I guess I'm getting a little tired here. And so yeah, it prints false. So our code is working. Sorry, this is way too much Trump in my life. I hate this. And so now let's actually try to do it as a real user. So, you know, this looks good. Give it a Y. Okay, it was 10 transferred to Alice, right? Now the second one here is 10 transferred from Alice to Bob. Signed Alice. It looks like everything kind of checks out. You know, the right person is signing these things. The amounts are the same. So I'm going to say yes. And okay, so now we could validate the coin. That's good. So sorry for some hiccups there, but like I said, I've had a long day. So we got this simple function that can check if the coin is valid or not, if the history of transfers makes sense. And so yeah, we basically have it implemented. And now we want to actually, you know, make it digital, make it so you could send it over the internet. And to do that, we'll need serialization. So serialization just means like, you know, like take our data and put it in a format that's like easily transportable, right? And the standard thing for Python is this something called pickle. It just takes Python objects and we'll put them into a binary format you can do whatever the hell you want with. And then when it appears on the other side, it can, you know, Python can utilize pickle a different programmer can utilize pickle to reassemble whatever you sent. And so let me just make sure I'm still recording here. Yeah, good, still recording. So let's import pickle and let's make a function serialize. Okay. You just return pickle.dumps. Dumps just takes a Python object, turns it into a binary thing. And so now we want a kind of a hybrid function. Let's call it toDisk. This will just take a coin and a file name, and we'll serialize the coin using pickle and our serialize function we just defined, and write it to disk. So we'll call it serialized equals serialize of coin, and then this is how you write write bytes to a file in Python. So that's what we're going to open on our system, and this is in what mode we're going to open it. So we're going to be W is for write, B is for bytes, and this pattern is called a context manager. It's nice because after this code executes, this open file will go away, so you don't, you know, end up with a bunch of open files in your system. And then we're just going to write our bytes to that file, right? So So let's test that our code works. So let's run a bash command here that just does ls on our local directory and then greps for a file we're going to create. So let's grep for, let's call it coin.pngcoin. Yeah, it's terrible, but that's what we're going to call it. Let's just call it bobs.pngcoin. Because this is we're going to use this coin here that we had, and this is Bob owns it now, so we're going to call it Bob. We've kind of left Bob out of the mixture here, so we're going to do that. We run and we don't see anything, right? And so we're going to run this again afterwards. So let's call toDisk and let's write the coin to this file, and then afterwards we will see if something happened on our file system. Oops, I never ran that. Okay, so I ran it, it worked, or something happened, and let's grep again. Okay, so look, when you list the files in our current directory and then grep for the file name we used, it appears. So we just wrote something to our system, our hard drive. Hopefully we wrote something that makes sense. We don't really know yet, but that's for this step. So to serialize, what we basically want now is we want to be able to let's be able to reverse this serialize function, and let's be able to reverse this to disk function too. So what we want to do is be able to read bytes off the disk and then deserialize them. So just reverse this whole process, right? So when you're sending PNG coins, this is what you'd do. You'd create the transfer, serialize it, save it to your file system, and then include it as an attachment in an email or something, or a text message or whatever. What the recipient would do is they would need to reverse this. They would need to be able to. They'd get a file. They need to load the file into their Python program, and then they need to deserialize it. And so that's what we're going to do here. So def pretty simple. And what we called dumps earlier, we call loads now. And so let us. We tried to we wrote this coin to disk. So let's try to. Well, actually, first let's make sure that our deserialize function actually does what we want it to. So let's try this. So. Let's just call it coin. That's the one we've been using, right? So let's serialize it and deserialize it, and then say let's check whether let's call it coin2, and then let's print whether actually you don't have to print in the last line of one of these cells, so you can do. Okay, there you go. So what we do is we serialize coin and then we deserialize it, right? So we're just kind of like running it through the washing machine here, and just check that deserialize actually reverses what serialize does, and it does. We can inspect the transfers and they're equal. So that's a good thing to know. And so next now that we've written deserialize, let's write from disk. It just reads the file given a file name. So when we read, this looks similar to the code we did for writing to the file system. And so here we use RB, so this is mode is reading bytes. And instead of calling write as we did above, we call read. And this will just give us a kind of a raw byte string back. And this byte string will be the serialized bytes, the serialized version that we got after calling. It'll be this. It'll be this what we created here, right? And then so to turn this into just a proper normal Python object, we're going to return. We're going to just return the serialized, the raw bytes we got. And so in order to test this out, let's call it coin3. And we call it bobs.pngcoin. And then we're going to check once more the same thing. So, read the coin. Remember, we wrote something to disk here. We wrote a file here. Let's read it. Let's deserialize it. And let's check that the transfers are equal. Good. It worked. So now we have this neat way to... we basically have implemented a tiny, unbelievably shitty, incredibly flawed version of digital cash. But you can see how it would work. You know, this would actually... you'd actually be able to send value using this method. You know, you could create a file and email it. And, you know, it kind of works. And so, so yeah, at the end here I have a link to this script. I made a script that's more of like a object-oriented version of this. The code's maybe a little cleaner. And so you can see some examples how to use that in the PNGCoin.ipynb. This is the finished version that I've been kind of cheating off of as I go here. And so here's some examples of how to use that. You know, it has some, well, I won't. Oh, why not? I think I just need to do this. God, I'm so sick of that picture, huh? So we can run this, and then we can it'll run the whole validation algorithm. I'll just stop it. Won't see that whole thing. It'll save to a file, and this will be able to read the file. So if we say yes a couple times, this is the most annoying program ever. Yeah, so then it'll give us two, it'll say, yeah, it validated if I give it 2 yeses. So you give it yes twice. And so yeah, so this is like, so I think that's kind of neat. It's, you know, this tiny little, here's the whole program. You know, like 50 lines of code or something. Very tiny. This is actually kind of digital cash. I hate to say it. I hate to say that I invented this, but I did, and it's terrible. And so, so yeah, let's kind of zoom back out and look at our journey here. So we started at we're on this second step here, this first step, PNGCoin. Hopefully, within the next, you know, pretty soon here, I'll release a video for ECDSA coin. That's an elliptic curve digital signature algorithm coin. So what we're going to do here is we're going to, you know, we're going to solve what's the most obvious problem here. Physical signatures are worthless in the digital world. We need something more secure. Enter digital signatures, and that's the main innovation in our next coin, ECDSA coin. And so, so yeah, that's the next thing we'll be working through, and I'll have that for you soon. And you know, we'll go to Bankcoin, we'll go to DivisaCoin, we'll go to Blockcoin. I'm basically here. I've written this code for Blockcoin, and this program's not like 300 lines of code. This has blocks. It has, you know, you can kind of guess what it has. And yeah, so this is, you know, please don't distrust me because I showed you this. It gets better and better, but yeah, play with this code and you know, let me know in Slack what you think. I can try to upload some kind of maybe homework for this, but yeah, I don't know if we want to play with it too much because it's pretty bad. But yeah, thanks for tuning in, and